Hello everyone. This is our fourth lecture of audio video engineering. In the second unit is digital TV and display devices. In the second unit, let us see the terrestrial transmission problems in analog television. In last lecture, we have seen the Mach signal and Mach transmission. In this, let us see what are the different problems in analog television. In the analog television, multipath interferences occurs, that is nothing but the ghost that occurs on the television signal. Noise interferences occurs, that is snow. Variable path attenuations, that is called as fading. Interferences to existing services, interferences from the other services, and channel frequency assignments, where to place the signal. The particulars that analog television transmission system does not understand itself, where to place that particular signal if there are number of signals present in that particular frequency. Now let us see what digital modulation does. What is the functions of digital modulation techniques, or what is the done in actually the digital television by using the digital signals and digital modulation techniques. It spreads the data evenly across the channel. It spreads the data evenly across this channel so that no data is particularly removed from that particular or lost from that transmission channel. Distributes the data in time. Whatever the data want to distribute, or whatever the data have to be transmitted, that is distributed in time within the time limit given. It maintains the synchronization well below data threshold. Employs the sophisticated error corrections, means whatever the errors are there, all the errors are corrected. Equalizes the channel for best performances. All these are the functions of a digital modulation technique in the digital television. Now let us see what is SFN, that is single frequency network. This particular single frequency network, it can help to solve difficult coverage situations. SFNs or single frequency network allows the reuse of transmission frequency many times. Same transmission frequency can be reused number of times in the same area so long as exactly the same program is carried. Allows lower power operations, better shaping of coverages, and improved service availability and better spectrum efficiency. These are all the functions of that particular single frequency network. Digital video is the most interesting of all the multimedia data. However, there is a price to pay. It requires maximum bandwidth of transmission and large space of for the storage. Means digital, whatever the digital TV, that gives us a very nice experience, that gives a very clear picture. It gives all the functions, all the multitasking is present in that digital video or digital television, but it requires a maximum bandwidth for the purpose of transmission and large space for the purpose of storage of data in case of digital television. For example, if you want to transmit the digital television color video with frame size 720 into 480 through a network in real time at a rate of 60 frames per second, you would require about 497 millions, that is equal to 720 into 480 into 60 into 24 bits per second of the bandwidth. This much amount of bandwidth is required for the purpose of transmitting that particular frame rate to different frame rate. This is too high a bit rate of for the consumer applications. Therefore, efficient video compression techniques are essential in order to make the digital video applications feasible. Means for the purpose of a proper proper pictures on the digital television, we have to use video compression techniques. Here we have seen the video compression technique in the digital television transmission diagram. We are using it for the purpose of compressing that video, and audio compressor also we have seen in that diagram. Now let us see. The compression is basically means reducing the image data. Whatever the image data we are having, we have to simply reduce. Compress is nothing but making it smaller. It reduces the image data. A digitized analog video sequence that can comprise of up to 165 megabytes of data. To reduce the media overheads for distributing these sequences, the following techniques are commonly employed to achieve the desirable reduction in image data. Means for the purpose of reducing image data, for the purpose of compressing the video, whatever the video we are having different techniques, that is reducing the color nuance within the image. We have to only reduce the current color nuances in the image, reduce the color resolution with respect to the prevailing light intensity, removing small invisible parts of the picture, and comparing adjacent images and remove details that are unchanged between the two images. Means small data, whatever is not needed at that particular video, that data is removed, so that we are reducing the image data. Means whatever the color differences signals, small signals that are very small, that cannot be catched by human eyes, that particular data that is not needed to show on the television receiver, that's why that particular data is removed by using the this compression method. Again, some of we are reducing the color resolutions with respect to prevailing light intensity. With respect to intensity, means as compared to the intensity, if resolution is higher, we can reduce that resolution and can bring it to the intensity level, so that image data can be reduced for the purpose of compression. As a result of this subtle reductions, a significant reduction in the resultant file size for the image sequence is achieved with little or no advanced effects in their visual quality. Means there are no changes in the visual quality. We are only simply making changes in the small details that cannot be exactly understand by the person who are watching the particular receiver. By changing this, we are making the video compression technique. The extent to which these image modifications are humanly visible is typically dependent upon the degree to which the chosen compression technique is used. Means we are, whatever the compression technique we are using, we will use it to the extent which cannot be catched by the human eyes. Often 50% to 90% of compression can be achieved with no visual differences, and in some scenarios even beyond 95%. Means we can compress a particular image or video 50 to 90%, and some of the images can be reduced to 95% also. This is nothing but the video compression technique, or what are the processes we are doing in the video compression technique. Now let us see the types of video compression. There are two types of video compression, that is lossless compression and lossy compressions. We are using here video compression technique in case we are using here compression technique in case of video and in case of audio also. Means for the purpose of audio we are using compression technique, that is lossless compression and lossy compression, and same we are using in case of video compression, that is motion video compression, that is lossless and lossy compression. Now let us see what is video compression here. What is video compression means? The video compression that refers to reducing the quality of data that is used to represent the video image, and it's a straightforward combination of image compression and motion compensation. This section deals with application. Compressed video can effectively reduce the bandwidth that is required to transmit the digital video via terrestrial broadcast, via cable, or via satellite services. Now let us see some of the things in motion video compression, that is video quality, how the video quality changes, how the compression actually occurs. Most video compression is lossy, that is, it operates on the premise that much of the data present before compression is not necessary to achieving good perceptual quality. For example, DVDs that we use a video coding standard called Mpeg that can compress 2 hours of video data by 15 to 30 times while still producing a picture quality that is generally considered high quality for standard definition video. In the video compression, like data compression, is a trade-off between disk space, video quality, and cost of hardware required to decompress the video in reasonable time. However, if the video is over-compressed in a lossy manner, it is visible or sometimes distracting the that distractions that can appear there. Generally, video compression is operates on a square shaped groups of neighboring pixels that are often called as macro blocks. These pixels groups or blocks of pixels are compared from one frame to the next, and the video compression codecs that sends only a differences within those blocks. Now let us consider a video that is having more motions. In that, more pixels can change from one frame to the next frame. When more pixels changes, the video compression scheme must send more data to keep up with the large number of pixels that are changing. If the video content that includes an explosion or flames or flocks or thousands of birds or any other image with a great deals of high frequency details, the quality that will decrease or the bitrate must be increased to send for a render that information with the same level of details. The programming that we provide has control over the amount of video compression that is applied to their video programming before it is sent to the distribution systems. The software that we are using for storing video on hard drives or various optical disk formats will often have a lower image quality that will be not in other cases. High bitrate video codes with little or no compression exist for the video post production work, but we create very large files, and these are almost never used for the distribution of finished videos. Now let us see what is actually the video. The video is basically a three-dimensional array of color pixels. Two-dimensional serves as a spatial, or we can call it as a horizontal or vertical directions of the moving picture, and one dimension represent the time domain for that particular. A data frame, that is a set of all the pixels that corresponds to a single time moment, that is basically a frame in the same as a still picture. Video data that contains a spatial or temporal redundancy. The similarities we can thus be encoded by merely registering the differences within a frame or between the frames. In the spatial encoding, that is performed by taking the advantage of the fact that its human eye is unable to distinguish small differences in color as easily as it can distinguish changes in the brightness. Okay, so very similar area of color that can be averaged out in a similar way to JPG image. With temporal compression we are using here, only the change from one frame to the next frame are encoded, as often large number of pixels will be the same on the series of frames. This is how the particular video is present and how we are using the video compression technique. Now let us see how video lossless compression occurs. Some forms of data compression that are lossless. We have seen lossy compressions now. A lot of data is lost. Now let us see how that lossless compression occurs. This means that when the data is decompressed, the result is in a bit for bit perfect match with the original. While lossless compression of the video is possible, it is rarely used. This is because any lossless compression system will sometimes result in a file or proportions of that is as a large or that has the same data rate as a uncompressed original data. As a result, all hardwares in the lossless system would have to be able to run fast enough to handle the uncompressed video as well as. This particular thing eliminates much of the benefit of the compressing the data in the first place. For example, digital videotape that can't vary its data rate easily. So dealing with the short burst of the maximum data rates, video would be more complicated than something that was fixed at the maximum rate all the times. This is how lossless compression occurs. Now let us see some of the compression formats. Mpeg has standardized the following compression formats that are Mpeg-1, that is in 1993, the coding of moving picture and associated audio for digital storage media at up to about 1.5 megabits per second. This is nothing but the bit rate. It was basically designed to allow the moving pictures and sound to be encoded into the bit rate of the compact disc. It is used on video CD and it can be used for low quality video on DVD's video. It was used in digital satellite and cable TV services before MPEG-2 was widespread. To meet the low bit requirement, MPEG-1 downsamples the images as well as uses the picture rates of only 24 to 30 Hz, resulting in moderate quality. It includes the popular MPEG-1 audio layer 3, that is MP3 audio compression formats. Means here it gives a performance where video quality degrades. In the second format, that is Mpeg-2, that was invented in 1995, generic coding of moving picture and associated audio information transports video and audio standards for the broadcast quality television. Mpeg-2 standards was considerably broader in scope and of wider appeal, supporting interlacing and high definitions. In Mpeg-2, it is considered important because it has been chosen as the compression scheme for over-the-air digital television, ATSC, DVB and ISDB, digital satellite TV services that are like Dish Networks, digital cable television signal and SVCD and DVD videos. It is also used on Blu-ray disc, but this normally uses MPG-4 Part 10 or SMPT VC1 for high definition contents. Now let us see the third one, that is MPEG-3. In that MPEG-3, it deals with standardizing, scaling and multi-resolution compression technique, and it was intended for HDTV compression, but it was found to be redundant and was merged with the MPEG-2. As a result, there is no MPEG-3 standard. So MPEG-3 is not to be confused with MP3, which is MPEG-1 or MPEG-2 audio layer third. Means in MPEG-1 and MPEG-2, for the purpose of audio compression, we are using MP3 technique, and this MPEG-3 is different than that. Let us see the next type, that is Mpeg-4, that was invented in 1998, coding of audio-visual objects. Here, Mpeg-4 uses the coding tool with additional complexity to achieve the higher compression factors than Mpeg-2. In addition to more efficient coding of video, Mpeg-4 that moves closer to the computer graphics applications. The Mpeg-4 decoder that was effectively becomes a rendering processor, and the compressed bit stream describes the three-dimensional shapes and surface textures here. Mpeg-4 that supports intellectual property management and protection IPMP, which provides the facility to use the proprietary technology to manage all the protect contents like digital right management. In the new higher efficiency video standard that includes Mpeg-4 Part 2 or simply an advanced simple profile, and Mpeg-4 AVC or Mpeg-4 Part 10 or H.264 that may be used on HD TV DVD and Blu-ray disc and along with the VC1 and Mpeg-2. Now let us see in brief how Mpeg-1, that is a standard for storage and retrieval of moving picture and audio on the storage media. In the Mpeg-2, a standard that is for digital television. In the Mpeg-4, a standard for multimedia application, and Mpeg-3 that was not used here. Mpeg-7 is also present, that a content separate representation standard for information search, and Mpeg-21 that offers a metadata information for audio and video files. Now let us see how an encoder works. This is the diagram for an encoder, ISO IEC 111723 encoder. Let us see PCM audio samples, how audio encoding occurs. Let us see PCM audio samples that we give at 48 kilohertz to the mapping block and mapping block as well as to the psychoacoustic model also. After that it goes through the quantizer and coding process, input to the quantizer and coding, the output of mapping and output of psychoacoustic model. After that frame packing is done, we will get encoded bit stream. Now let us see what is the work of mapping block. This mapping block divides the audio inputs into 32 equal width frequency subbands or samples. Psychoacoustic block that calculates the masking threshold for each subband. We are having number of subbands. With that number of subband, it calculates the masking threshold for each subband. Bit allocation block is allocates bit using outputs of the mapping and psychoacoustic block. Quantizer and coding block scales and quantizes, that means reduces the samples. Okay, and frame packing block formats the samples with the headers into the encoded bit stream. Now let us see what are the differences in the three MPEG standards: MP1, MP2 and MP3. MPEG layer differences lie in processing power and resulting audio sound quality. That is, MP1 little processing is needed and it gives a poor quality. MP2 here minimum processing is needed and it's having okay quality, means better than poor quality. In MP3 massive processing and high quality is present for the audio. In the MPEG-1, we will see how video and audio compression occurs. Substantially, it reduces the bandwidth that is required for high quality transmission and it optimizes the balance between resolution quality and bandwidth. Now let us see different parts that occurs or different states that occur in the MPEG-1. In the first part, it combines the video and audio data into the single or multiple streams. After that, in second, it offers more advanced video compression tools. In the third part or third step, it is a multi-channel extension of MPEG-1 audio standard is given. In next step, it corresponds to build on part 4 or 5 of MPEG-1. It specifies the protocols of managing MPEG-1 and MPEG-2 bit streams. It specifies a multi-channel audio coding algorithm. It was discontinued because of obsolescence. It specifies the real-time interface RTI to transport stream decoders. Part 10, the conformance part of digital storage media that commands and controls currently under development. Let's see how video stream or how a video is present, means what are the components present in a video. Consider a video sequence. We are having a total sequence of video of 1 minute. Consider it consists of groups of pictures, means number of images are grouped or that are present at a one by one sequence. That is nothing but a video, particular video, groups of picture. One of the picture, let us consider one of the picture or one of the image. That particular picture consists of number of slices present in that particular picture or image. That slices consist of number of macro blocks. One of the slice consists of number of macro blocks present in that, and whatever the macro block we are having, it consists of number of pixels in present in that particular macro block. So means first we are having video sequence, after that group of pictures of images. We are having different slices present in that images, different macro blocks present in slices, and pixels present in that particular macro blocks. This is nothing but the video stream data hierarchy. Now let us see in detail what is actually the video stream. The groups of picture is nothing but a video stream. Iframes that can be reconstructed without any reference to other frames. P frames that are forward predicted from last iframe, and p frames means whatever pre-frame that is forward predicted by the iframe. Iframe is original first frame that is present about the image or reference frame. After that pre-frame is for predicted before it present, and b frame that is forward and backward predicted. Let us see in diagram. Red one is iframe. P frame is exactly after the particular that particular iframe, and b frame That B frame is forward and backward predicted, means whatever the original frame, the forward and backward data of that frame is present in B frame. In the P frame we are having the forward predicted data of any frame, and I frame is nothing but the starting or the reference frame of the particular video stream. Compression. This compression eliminates the redundancies. The spatial redundancy, that is pixels are replicated within a single frame of video. Same pixels are replicated in the same frame of video. Or temporal redundancy, that consecutive frames of video display images of the same scene. Let us see in diagram. In first 3 we are having temporal redundancy, that is interframe, and in second intraframe, that is spatial redundancy. Okay, getting it from the image. Now let us see the different video compression techniques. Till now we have seen what is actually the video compression and standards of the video compression. Also we have seen mpeg1, mpeg2, 3, 7, 21, like that. Now let us see video compression techniques. Pre-processing, temporal prediction, motion com- compensation, and quantization. These are the 4 compression techniques of the video Before going in detail, now let us see. We have seen what is the video. Video is nothing but the sequence of pictures, and each picture that consists of arrays of pixels, means number of pixels are present in that particular picture. For an uncompressed video, its size is huge. Whatever the video that is uncompressed, it is having very big size, so that for a big sized video, the data rate also should be very big for the purpose of transmission. This high data rate is too high for user level applications, and it is big problem for CPU and communication purpose, higher bit data rate. To deal with this problem, video compression technique that is used for the reducing the size of that particular video stream. Now let us see the first technique, that is pre-processing. In the pre-processing, that pre-processing process filters out the unnecessary information, that is difficult to encode and not an important component of human visual perception, means it cannot be catched by the human vision. That particular can be filtered out or removed from that particular data. Next is temporal prediction. In the temporal prediction, it uses the mathematical algorithm discrete cosine transform to divide each frame into 8 by 8 blocks of pixels, reorganize the residual differences between the frames, and encoding each block separately. That is the purpose of temporal prediction. A natural algorithm we are using here for the discrete cosine transform to encode the blocks separately and to reorganize the residual differences between the frames. Now let us see in this diagram, whatever the picture we can see on the screen, that is a baby and his mother. The picture that is shown by the 8 by 8 pixels, that particular side of the picture, that is not so much necessary. That particular picture can be removed, or that can be filtered out here by using the pre-processing. This figure shows the temporal prediction, where a difference is found out in between the original picture, previous picture, and by using that difference, new picture is formed for the purpose of encoding. Now let us see the third type, that is motion compensation, or third technique here. Try to match each block in the actual picture to contain in the previous picture. Matching is made by shifting each of the 8 by 8 blocks of the two successive picture pixels by pixels in each direction. Motion vector, subtract the two blocks, that is difference block. Transmit the motion vectors and the difference block. Means in this case we have to match actually original picture, previous picture, and next picture, and each it is matched by pixel to pixel. It is divided into 8 blocks, and each and every pixel is compared from the first picture to second picture, and we have to subtract the 2 pixels so that there will form a difference between the 2 pixels or 2 blocks. This is how the motion compensation technique works. Next one is quantization. In the quantization, it refers to DCT coefficient. It removes subjective redundancies. It controls the compression factor and converts coefficient into the even smaller numbers. This is how the quantization works. Now let us see where we are using this compression techniques. We are using it in the multimedia communication, webcasting, broadcasting, video on demand, interactive, digital media, telecommunication and mobile communication. Everywhere in the digital communicate for the digital communication purpose, everywhere we are using this data compression technique so that we can have the less bit rate for the purpose of transmission. Now let us see where we are using this television standards. The particular JPEG standard that is applicable for the still image compression, and H.261 that is for video conferencing over ISDN, MPEG-1 and MPEG-2 is for the digital televisions and for the digital storage media also. H.263 we are using for the video telephony over the PSTN, as well as MPEG-4 standard is applicable over object based coding and synthetic content interactivity. In the JPEG 2000 it improves the still image compression, and in the MPEG-4 and H.264 it is applicable over the improved video compression. Now let us see the applications of video compression. It is for distance learning, means whatever the video we are using, that compression technique we are using for distance learning, for video conferencing, for telemedicine, for broadcasting purpose, for surveillance, for video on demand and broadcasting TV. Let us see how the conferencing occurs. Room to room conference, for that purpose we are using this video conferencing technique, where we record a particular whatever the meeting or conference is going on, that particular is recorded at one place and that can be showed on the another place. In second, desktop. In the conferencing of the desktop means number of people from one desktop can interact with the number of people at the another desktop. Multi-point. In the multi-point we can see there is a conference that is going on at three places, means from one place one particular person he is contacting with the another person at another point, and at the third point, means multi-point we are using here. At the third point the people they are interacting with the people that are at the first and second point, that is nothing but the multi-point. In live broadcasting, for the purpose of live broadcasting, when a particular person he is presenting the live, that particular is being recorded and that is transmitted or that is broadcasted at number of different points. Pre-recorded broadcasting, whatever we are recordings we are having at one place, that particular recording we can send or we can show to at different points, that is broadcasting for the pre-recorded purpose. Broadcasting video distribution, for purpose of video distribution at domestic purposes, means whatever the particular information that is broadcasted from one antenna, that is distributed over home to home. Distribution is done here at number of places, that distribution is done, and that is received by the receiving antenna. The next case is video on demand, means here we are having all the videos that is pre-recorded. Video on demand means different users can watch different videos, means on video on demand one particular using is watching one channel, second user is watching second channel, third user is watching third, fourth, like that. Video on demand, whatever the particular person can watch, that is watched at different places. We are having different video compression standard, that is motion JPEG, JPEG-2, MPEG-1, MPEG-2, MPEG-1, H.261 or H.263 as we have seen in the before, MPEG-4 also. We are using for different purpose. Let us see the motion JPEG. Motion JPEG we are using for the recording motion picture, whatever the picture that is being recorded. Means here we are compressing the data that was originally present. Means consider for example a car in the car racing. In the first picture the total image we can see about the car. In second picture we can see the image, same image but at the different place. Means at the next place, that particular racing car is going to the another place. All that particular data is similar, only we have to change that particular position of that car. In that case we can compress, that is spatial compression is occur here, and we can use the compression technique for the purpose of compression. Now let us see Mpeg 1 compression. Motion estimation is also allowed over a greater range. It results in significant higher quality. Forward predicted frames that are called as P frames, we have seen before, that are allowed macro block predicted from past P frames or iframes, or macro blocks that are coded from the scratch. Iframes and P frames that are used to past and future frames for bidirectional prediction frames that are called as B frames. B frames we are having, which gives the predicted before frame and forward predicted after frame. This is simplified for the Mpeg compression. Now let us see the Mpeg sequence. In the Mpeg data compression, whatever the particular images or particular moving video we are having, it is having number of sequences over the number of time. Means at different instances of time we are having different images, as we can say in the image. Now let us see the iframe. As we have seen before, iframe is nothing but the reference frame. We are having two reference frames. One is starting reference frame and one is ending reference frame, where we have to stop the video, and starting is nothing but where we have to start the video. These are nothing but the iframes. In the P frames, P frame is nothing but the forward predicted frame. Whatever the first frame we are having, the forward predicted to the first frame, to the reference frame, that is nothing but the P frames. And B frames are nothing but forward and backward predicted frames. Means after the first, whatever the forward frame, that is second, then third, fourth, whatever the fourth frame, P frame we are having, for that particular fourth frame, backward predicted frames are second and third, and forward predicted are 5 and 6. These frames are present here. For the seventh frame, forward predicted are 8th and 9th, and backward predicted are 5 and 6. All these frames are present by using the B frame. Thus in this way we are doing the compression technique. These are all the video conferencing standards: ISDN H.321 and LAN H.323. All these are standards for video conferencing. And these are some of the audio compression standards. Thank you.